Chemical Equations Part 2. Writing and balancing chemical equations. To write and balance a chemical equation, we first start with the word equation. For example, potassium metal plus oxygen gas produces potassium oxide. We write the skeleton equation without any states shown. K for potassium metal plus O2, oxygen gas, produces K2O, potassium oxide. This equation is not balanced because it doesn't show the same number of atoms on each side of the equation. It shows one potassium on the reactant side, but two potassiums on the product side. We know this isn't possible because matter cannot be created or destroyed, and this equation implies that one potassium atom was created in this reaction. Similarly, it shows two oxygen atoms on the reactant side and only one on the product side. This implies that one oxygen atom was destroyed, and this just doesn't happen in nature because matter is neither created nor destroyed. So clearly, the way this reaction is written is not exactly the way it occurs in nature. We need to balance the equation and show exactly how many potassium atoms combine with exactly how many oxygen molecules to produce exactly how much potassium oxide molecules. So we write the balanced equation, and this equation is balanced because it shows the correct number of each type of atom on the reactant side and the product side. So for example, on the reactant side we see 4 potassium atoms, and on the product side we see 4 potassium atoms, 2 in each one of the 2 molecules. On the reactant side we see 2 oxygen atoms, and on the product side we see 2 oxygen atoms because there's 1 oxygen atom in each potassium oxide molecule, and there are 2 potassium oxide molecules present. Let's take a look at how atoms are counted to balance a chemical equation. We'll take this equation. Methane plus oxygen produces water plus carbon dioxide. This is a combustion reaction. It occurs whenever methane gas is burned in the presence of oxygen. The methane molecule is made up of 1 carbon atom and 4 hydrogen atoms. It looks like this. The black circle represents the single carbon atom, and the 4 blue circles represent the 4 hydrogen atoms. It combines with 2 oxygen molecules, and the 2 molecules of oxygen have a total of 4 atoms of oxygen, 2 in each one of the molecules. It would look something like this. Here we see 2 atoms, or here we see 2 molecules of oxygen. When methane and oxygen combine or react, they produce water and carbon dioxide. Specifically, there are 2 water molecules produced, and in each water molecule there are 2 hydrogen atoms, so that gives us a total of 4 hydrogen atoms altogether in 2 molecules of water, and there are 2 molecules of oxygen shown because there's 1 in each one of the 2 water molecules. That would look something like this. Here we see 2 molecules of water, and each molecule of water has 2 hydrogens and 1 oxygen. Carbon dioxide is also formed, and in carbon dioxide there is 1 molecule of carbon dioxide, and it contains 1 carbon and 2 oxygen atoms, and it looks like this. So as you can see, the total reactants on the left hand side are equal to the total products on the right hand side. What I mean by this is that if we count up the total number of carbons, hydrogens, and oxygens in the reactants, it's equal to the total number of carbons, hydrogens, and oxygens in the products. We can count them up and prove this to ourselves. Remember, there's an imaginary sort of division here separating the reactants from the products. We have to have equal numbers on both sides of each. So on the reactant side, we have 1 carbon atom, and on the product side we have 1 carbon atom. On the reactant side we have 4 hydrogen atoms, And on the product side, we have 4 hydrogen atoms. And on the reactant side, we have 4 oxygen atoms. And we have 4 oxygen atoms on the product side. The reason this is important is because it shows that no matter has been created or destroyed. The atoms have just rearranged themselves. It's important to balance a chemical equation to show this. Here's some hints for writing word equations. Some correct chemical names do not follow naming rules that we learned earlier. You will need to memorize these. They include glucose, C6H12O6, water, H2O, methane, CH4, and ammonia, NH3. In addition, you will also need to memorize the diatomic elements: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Here are the rules for balancing equations. Add coefficients only to the front of formulas, and do not change the subscripts. Strategies for balancing chemical equations. Start with trial and error. Balance compounds first and single elements last. Finish balancing all atoms in one formula before moving on to another. When oxygen or hydrogen appear in more than one place at the same time, balance them last. Polyatomic ions can sometimes be treated as one single unit. And once you finish balancing, check to be sure that all elements are balanced. You'll be using these strategies as you practice balancing equations, so don't worry if you haven't memorized them all right now. However, you should check your textbook on page 209 and keep that open when you're balancing equations, just so that you can refer back to these strategies.